Now here's a big topic, converting fractions into decimals. Tables like these are really useful when converting fractions to decimals. Notice the tenths column, hundredths column, and thousandths column. You'll also notice the decimal point, obviously, and then the units of ones, which will all be a 0. As you can see here, 0.4, well, that's the same as saying 4 over 10. 3 over 10, well, it's the same as saying 0.3. You can go ahead and throw in the extra zeros, but it means the exact same thing. 0.300, same as 0.3. The next fraction, 6 over 100. Well, you put a 6 in the hundredths column. Don't forget the 0 there in the tenths column. 0.06 is 6 over 100. Now the next one, 9 one-thousandths. So you put a 9 in the thousandths column. 0.009. Here's some more fractions to throw into our table. 23 over 100. Well, it's the same as saying 0.23. 650 thousandths. Same as saying 0.650. And notice the 0 in the thousandths column. However, you can chop off that 0. So it becomes 0.65, which is the same as saying 65 over 100. Means the same thing. Next fraction, 50 over 100 is 0.50. However, you can again chop off that 0. So you've got 0.5 or 5 over 10. Next fraction, 500 over 1000. 0.500. Once more, we can get rid of some zeros. Because 0.500 is the same as saying 0.5, or simply 5 out of 10. Oh, holy dolly! Check out those denominators. You'll see they don't have a 10, a 100, or a 1000. They've got 5, 50, 25, and 20. So therefore, it's going to be a bit different transferring these fractions into our table as a decimal. But notice the first one, 2 out of 5. If we multiply the bottom and the top, it becomes 4 out of 10, which means we can put that 4 in the tenths column, 0.4. 3 out of 50, well, we can make that 50 a 100, can't we? So we multiply that 50 by 2, we must multiply the top by 2, so that's going to be 6. So 0.06, because that 6 goes in the hundredths column. 4 over 25, well, 25 times 4 will give you 100. So therefore in the numerator, 4 times 4, that'll be 16. So 16 100ths, we can then slot into our decimal table, 0.16. 6 over 20, well again, that denominator we can multiply by 5, so therefore the top we can multiply by 5. So we've got 30 out of 100. There you can see in the table 0.30 or 0.3. So in this sense you can see 2 over 5 is 0.4. 3 over 50 is 0.06. 4 out of 25, that's 0.16. 6 out of 20, well that's 0.3. Alright folks, things are going to get a bit hairier now. Let's appreciate this fraction here visually, and then there's an algorithm. So visually we can appreciate here that 1 out of 4, well there's a chocolate bar, it's got 1 coloured in, out of 4 pieces. So what we need to think about here, that line, it's called a vinculum. Weird name, right? But the main thing is here, it's division, 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 division. Remember, it means division, 1 divided by 4. So whatever number's on top, you divide it by the number on the bottom. So 1 divided by 4. So if we do it here in this context, it can help us create the decimal. So we can see 1 divided by 4. Well, how many times does 4 go into 1? It goes no times. So therefore we put the number 1 over there and we say, well, how many times does 4 go to 10? It goes twice. The remainder is 2, which we put down below. How many times does 4 go to 20? It goes in 5 times. There's your decimal, 0.25. 2/5, 2 over 5. Let's appreciate this fraction visually. There's our delicious chocolate bar. We're going to divide it up into 5 pieces. Oh, and I'm going to now eat 2 of them. 1, 2. Delicious. We're going to put this into an algorithm now, because we remember that that there means division. So we've got 2 divided by 5. And this is how we create our algorithm below. How many times does 5 go into 2? Well, it doesn't go. So we put the remainder down there. How many times does 5 go into 20? Well, it does go in perfectly, doesn't it? 0.4. So there is your decimal for 2 over 5, 0.4. 1 over 8. 1 divided by 8. Chuck that decimal point in. Now let's go. How many 8s go into 1? 0. So your remainder is going to be 1. How many 8s in 10? Well, there's 1. The remainder is going to be 2. How many 8s in 20? 2. And your remainder is going to be 4. How many 8s in 40? What goes in perfectly? 5. So there you go. 1 over 8 equals 0.125. Right, last one. This one's a bit crazy now. 2 over 7. So that means, again, 2 divided by 7. So here we go. We're putting out our algorithm, putting the decimal point in the right place first, and throwing in some zeros after the 2. How many 7s go into 2? 0. Your remainder is 2. How many 7s into 20? Well, it's going to go 2 times. The remainder is going to be 6. How many 7s in 60? Well, there's 8 7s in 60. 7 8's 56. So therefore your remainder is going to be 4. How many 7s go into 40? Well, 7 5s are 35, so it goes in 5 times. The remainder is going to be 5. How many 7s therefore go into 50? Well, 7 times 7 is 49. You can see we're going to go on for a while here. So we might just leave it there. 0.28571. Well, let's just focus on the first few numbers after that decimal point. 285, 0.285. 2 over 7, well, the decimal is 0.285. Or, if we want to round it to just 2 decimal places, that's going to round up. The 8's going to round up to 9, so it's going to be 0.29. Yeah, nice, well done. That was a long clip. I hope you learned a few things.